Hey guys, welcome to Living the Logic. This is Manish Narayan, and today we're going to build a generic Node.js message bus that'll be capable of talking to Kafka, RabbitMQ, and Redis. And down the road, we can add more brokers such as AWS, SES, SNS, and so on. So here, basically, we have a Node.js worker that's scalable, and it can publish thousands of events, and those events based on a config value, it can they can arrive at Kafka, RabbitMQ, or Redis. Okay, so we'll focus in this video today on building the universal or generic message bus that's capable of talking to Kafka, RabbitMQ, or Redis, and then we'll test out an example with test events and handlers for RabbitMQ. Okay, so basically, events, we have a publisher, right? So the publisher will publish events to Kafka, RabbitMQ, or Redis, all right? And each event has an event handler. So for example, a user created event will have a assigned or mapped user created handler, okay? Order placed event, we have an order placed event handler, right? So again, a very simple, I'm going to keep this very clean. It's going to be running on Docker, all right? It's going to be on a Docker container as a worker, and you can scale these guys, and you can apply it in real world. All right, so let's get started. All right, the first thing you want to do, make sure you have Docker installed. I'm assuming you already have Docker installed, Docker Desktop. Um, I have that running here. It looks just like this. Okay, you'll see it, Docker Desktop. All right. I do have maybe an outdated version. Again, feel free to update your Docker Desktop, get the latest version. Okay. Next, you're going to open up a command prompt and go to any development folder. I'm going to be in my C:\development Udemy. Also, be sure to check out my Udemy courses. I have a lot of courses on different subjects, so if you need a discount coupon or anything, just let me know. So the very first thing, we're going to create a new directory. So we'll say make directory, and we'll call this our universal message bus. Okay. All right, and we'll cd into that. Okay, so the very first thing we want to do is create a Node app. So initialize a Node.js app. So we'll say npm init -y. All right, so it's set up, package JSON and some basic settings for the Node app. Okay, and then once we're in there, what we'll do is we'll create a new directory, make directory, and we'll create a source directory. All right, so if you hit dir, you should see a package JSON and a source directory. All right, next you want to open up VS Code or the IDE of your choice. I'm using VS Code in this video, so I'm going to go ahead and open the new folder up. All right, that's going to be under C:\development demi, and we'll have a universal message bus here, and I'll open that folder. Okay, so we should see a package JSON in there, right? So once you see the package JSON, what we're going to do is create a start script, right? So inside of scripts, we'll go ahead and add a new attribute. We'll say start, so we can run npm start. Okay, basically this is going to kick off the Node app. So Node will go into our source, and it'll run our index.js, which we'll create in a second here. Okay. I'm going to add some dependencies now. Again, the versions just, they might be slightly outdated, but should be working. All right, so we'll add a dependencies section here. Okay, the very first thing we're going to add is an AMQP dependency. So AMQP and lib. So AMQP lib, and that version is going to be anything greater than 0.10.3. Okay, we're also going to be talking to Kafka, so Kafka.js. All right. Again, feel free to use other libraries that you use to interact with RabbitMQ or Kafka. I'm using Kafka.js and AMQP-lib. All right. So here the version is 2.2.2, and then we'll need Lodash package. Okay, that version is going to be 4.17.21. Okay, and finally Redis, all right, to communicate with Redis. So here, basically I'll have 4.5 4.5.0. Okay, so I'll save that. Next, just to test this out before we run Docker or anything, I'm going to just add a source file. So inside source, you're going to add a new file. Call that index.js. Okay, and inside index.js, basically we can just say console.log, and here we'll just say worker is starting. Okay, very simple. I can open a terminal. So I'll open a terminal. What I'm going to do is run npm install, to get all the packages installed. Okay, and then I should be able to run npm start. All right, so if everything's good, we should be able to run npm start. Okay, great. So it prints out whatever is in index.js, right? So worker is starting. All right, beautiful. Let's set up Docker and the RabbitMQ dependency, and we'll create this index into a worker. All right, and then we'll start to build our universal message bus. All right, great. So what I'm going to do is minimize this. I'm going to go ahead and close up package.json index.js. In the root of the folder, what we're going to add is our Docker file. So what I'll do is collapse source, new file, and we'll call this Docker file. Okay. So here, I'm going to add the basic Docker commands. So node, here I'm using the image 20 Alpine. Okay. So we'll create our work directory. All right. So that's user source app. Okay. Basically, we'll copy all the package files from our Node app. So copy package.star or package.star.json, okay, into the folder, and we'll install all the packages. So run npm install, and we'll say omit dev, equals dev. Copy the files, okay, and then finally we'll kick it off with npm start, just like we did on the console. So we'll say we'll give it a command, and we'll say npm start. Okay, so that should take care of our Docker file. All right. Next, we want to build our Docker Compose so we can start to run all of our services, the worker, including the worker, and RabbitMQ. So again, in the root of the directory, I'm going to add a new file. We're going to call this docker compose.yaml. Okay, so here I'll give it a version 3.9. Okay, and we'll start to create our services. All right, so the very first service we're going to have is our app, basically our Node.js app, right? So we'll say app and say build dot and the container name. This is important. So the name of our container, this can be our universal message bus. Okay, and it depends on, so basically it should depend on RabbitMQ, right? So we'll say RabbitMQ, and we'll set up an environment here. Okay, and I'm going to delete the default here. So we'll have environment, and the first thing is RabbitMQ URL, AMQP, and username is by default guest, password is guest, at RabbitMQ, port 5672. Okay, and then our node worker will run on port 3000. Okay, it's a standard node port. All right, we'll create a volumes, and we'll say this is our user source app. Okay, and then we'll say the command is basically npm start to start the worker, and set up the ports here. We put a tab here. All right, ports. Remember, the worker is node, so it's going to run on 3000. All right, we'll add a restart unless stopped. Okay. So that should do it for our setup of the node worker. Next thing we need is RabbitMQ, and that's the last thing we'll need here. So RabbitMQ, it's another service we'll define. Image, we'll grab the latest image that includes a RabbitMQ management plugin. So RabbitMQ 3-management. Okay, and container name, and that's going to be RabbitMQ. Keep it simple. Remember, RabbitMQ runs on, exposes two different types of ports, one for the management plugin, one for the RabbitMQ itself. service. So here we'll have 5672.72. Okay, and this is for, we'll just put a comment here. This is for RabbitMQ and port 15672, 15672, and that's the management plugin. Okay, that's going to be the management UI or plugin. All right, we should have an environment here. So two variables in the environment. So RabbitMQ default user, that's guest, and RabbitMQ default password, guest. Okay, and again, we'll set up restart unless stopped. Okay, so this should take care of the Docker Compose. Okay, we'll run our app and RabbitMQ. Right now, we don't have any worker yet, basically any message bus. We're going to create that in a moment. But if you wanted to test this, you can actually just say npm, or sorry, Docker Compose build. So let's just see if it builds here. Move this up a bit. Should run the npm I, right? And should be quick because we don't have much code yet for the message bus. Okay, and then I can run Docker Compose up -d. All right, so starting the containers, if I head over to okay, so if I head over to the container, we see Universal Message Bus, great. RabbitMQ is live, and then if I click into the Universal Message Bus, worker is starting. It's just repeating, right? So we're going to get our worker set up now. All right, so looks like our Docker files are looking good. Let's build our universal message bus that can talk to Kafka, RabbitMQ, or Redis. All right, so in order to stop it, I'm going to run Docker Compose down -d. Oh, sorry, -v. Oops. There we go. Okay, should be able to stop. It should be stopping the containers. All right, so Docker looks good. I'm going to go ahead and close or minimize the terminal. You can even close it for now. I'm going to close the Docker Compose and the Docker file. So that looks good. Let's build our universal bus. So basically, we want to be able to talk to Kafka, RabbitMQ, and Redis, and other buses or brokers. So we want to build out some base classes, all right? So some interfaces. You can think of as a generic interface, and then we'll be able to implement those interfaces, okay? So very first thing under source, I want to start creating a message bus folder. So we'll create a message bus folder. Okay, inside message bus, we're going to have some interfaces, all right? So one interface, so we'll say, oh, did I create a folder? Yeah, so, oh, I think I created a file, sorry, let me delete that. Delete. Okay, so inside source, new folder, not new file, so new folder, and that's going to be message bus. Sorry about that. All right, so inside message bus, basically we're going to have two folders. One for interfaces, so new folder, we'll call this interfaces. All right, and then inside message bus, we'll also have our mappers, and I'll show you what that is. Basically, our event handlers need to map to events. Okay, so we'll have mappers. Okay, so inside the interfaces, the very first thing we're going to do is create a base class, right? So any type of message bus should implement this base class, right? So under interfaces, I'll add a new file, and that's going to be called messagebus.js. Okay, so we'll define a class here, and let me zoom in. So go ahead and squeeze this over. All right, so we'll define a class called messagebus. Okay, so we'll have a constructor, right? So the constructor will take in some options, okay, like what type of bus it is, things like that, right? So we'll have some options there. We'll say this dot options equals options. All right, and we'll put in a check here. Basically, if this dot constructor is equal to message bus, okay, we'll say throw new error. So basically, we're making it an abstract class, right? So we're not allowing anyone to instantiate this message bus, but they got to build. Clients have to build their own type of bus and implement it, right? So we'll throw a new error here, and we'll say abstract class message bus cannot be instantiated. Okay, throw an error. Great. So that should be our constructor. Very simple. Now, basically, what do message buses do? Well, they publish messages to a queue or topic, and they subscribe. Okay. So we'll say we'll create a publish method. So publish queue or topic and pass the message. Okay. So basically, the base class will just log. It's not really going to perform any sort of communication with any bus. It's just logging here. So we'll say publish, and here $, we'll say message to the queue, $, queue or topic. Okay. All right, that's the publish base method publish, and then we'll have a subscribe. So we subscribe to a message. Okay. We'll say console.log, and we'll say subscribe to $, message. Okay. And sometimes for Kafka or other types of bus, we'll need a convert method. So I'm just going to put here async convert message in case we need it later on. I'll say constant message value equals buffer dot from, and here we'll say message of base64. Okay, and we'll say toString. Okay, and we'll just return using JSON helper json.parse message value. Okay, in case we need that. All right, so this is our base class, so nothing complicated. We'll just write an exports here. Exports, and this is called a message bus. So now we can use this class, this abstract class, in implementing our concrete buses. Okay, so let's close up message bus. Now we'll need some mappers. So basically, think of it as a dictionary that'll hold who the event handlers are and which events or queues they're bound to, right? Or subscribed to. So the very first thing, we're under mappers, we're going to add a new file. And this, we're going to call it the event subscription mapping.js. Okay, so define the class here, event subscription mapping class. Okay, we'll have a constructor, not pass anything in. We'll say this dot class mapping is an empty array of objects. This dot instance is null. All right, so what do we do here? So basically, we'll write a getter here and a register method. So getter class name options, and this will get us our event subscription mapping. So we'll say if instance or this dot instance dot constructor dot name is not equal to the class name. Okay. We'll say if type of this dot class mapping, and we'll pass in. So think of it as a dictionary. The class name, we're just holding a mapping as a dictionary basically, is not equal to undefined. Okay, and here we'll just say this dot instance is equal to new this dot class mapping, and we'll pass it the class name, and we'll pass it some options. Okay, and then we'll return the instance. So this dot instance. Okay, that should do it for the getter. Okay, and then we'll have a register method here. Register class name. And here basically we'll kind of loop through the classes here. We'll say if array dot is array class name. Okay, and we'll say class name dot for each. And here say m. Okay, and we'll say this dot class mapping, and we'll pick up the name of the class equals m. Okay, semicolon there. And here we'll say else this dot class mapping class name dot name equals class name. Okay, and we'll export this. So think of this as a event subscription dictionary that holds the classes and the class mappings. Okay, so we'll say module.exports event subscription mapping. Okay, I'm going to go ahead and close that. All right, so when we're done with this, we need one more type of mapper, which is called a pub sub provider, publisher subscriber provider mapping. All right, so I'll add a new file under mappers, and this would be called the pub sub provider mapping.js. All right, so here, this is an important one. This is where we set up, all of our types of buses. Okay, uh, we haven't created them yet, so just keep this file empty for now. We'll get back to it as soon as we have our buses defined. Okay, so I'm going to close this file for now. All right, so let's create our first bus and implement our interface. Then we'll set up our pub sub provider, the file we created just a moment ago. So the very first thing to do is under message bus, we're going to create our first bus class, which is going to be interacting with RabbitMQ. So I'll say new file, and this should be under, let's collapse mappers. So under message bus, we need a new file, and that's going to be called our RabbitMQ bus.js. All right, so let's start using some of our libraries to talk to RabbitMQ. Okay, remember we're going to implement or extend our base class, our abstract message bus class. So we're going to say constant RabbitMQ equals require AMQP-lib. All right, we're also going to need Lodash here. So underscore, and that's going to be Lodash. Okay, and we'll bring our message bus. So message bus, and here we'll require, and basically go into our interfaces, message bus. Okay, and we'll need our event subscription mapping. All right, so event subscription mapping. So if you go to our mappers, remember we had an event subscription mapping here. So we'll say constant event subscription mapping equals require, and that's going to be just a folder up to mappers / event subscription map. There it is. All right, so let's define our first class, our RabbitMQ class. So RabbitMQ, and this extends our message bus. Okay, so add a constructor, pass it some options. Okay, and here we'll call super, which is a base class, and pass it the options. Okay, we're using a little bit of OOP here in Node.js. So we'll say we'll define a set of queues here. Okay, and then we'll call init. Okay, we'll have a method for event init. Okay, and this is an important one. So we'll say if there is no instance of mapper, we'll say this dot mapper equals new event subscription mapping. Okay, and we'll return this dot mapper. Okay, now let's create our init method. Basically, this is our connection to RabbitMQ. All right, so we'll say async init And here we'll define a broker. And if it's not already in the options, we'll check. So this dot options dot rabbit broker. Okay, if there is a broker defined, all right, we'll just say broker equals broker dot replace username this dot options dot rabbit username. So this is again if we have our env files and we're gonna replace username and password. And then here we'll just throw in a dot another replace, and we'll replace the password this dot options dot rabbit password. Okay. Now we define our connection. So this dot connection equals await, and we'll use RabbitMQ library for connect. So if there's a broker defined, otherwise it's just AMQP forward localhost. Okay, it'll define a channel. So once you have a connection, you need a channel. Stock connection dot create channel. Okay, and we'll return this. Okay, so basically, we'll initialize a connection to RabbitMQ. Okay. Now we want to be able to implement our publish method of our base class. So async publish, define the queue and the message. Very simple. You want to publish to a queue? Well, define a queue and a message. Okay, we'll say if there's no connection, we can call init. Okay. Otherwise, we're going to await this dot channel dot assert queue name, and we'll define as durable true. Okay, and then this dot channel dot send to queue. All right, so basically we're publishing at this moment to the queue the message. Okay, and we'll stringify our message. So buffer dot from JSON dot stringify and message. Okay, and this publishes it to our queue. All right, so that's how we publish to RabbitMQ queue. All right. Okay. Now subscribe is going to be a little involved because we're going to basically it's very generic. It's like, hey, what's the name of the queue? Is there a handler that exists for it? Go to our basically go to our mapping, right? Our subscriptions and invoke the handle method of the event handler, and we'll define test handlers in a moment. Okay. So here I'm going to define an async subscribe method. Okay. Give it a queue name, a handler, and some options. First thing we want to define is mapper. And remember, we get it from this dot event init. Okay. And here we'll register the handler. Okay. Register the handler. So every time we call subscribe, we get a dictionary, remember, of handlers that are attached to a queue. Okay. So that's the register. Again, if here we'll check if there's no connection. We'll go ahead and await this dot init. Okay. Now, we're going to do a check here. We'll say this dot queues. If the list of queues exists and the queue name is in that dictionary of queues, we're going to say get the existing handler. And here we'll use lodash dot find this dot queues queue name, and we'll say h equals handler. Okay, so if there's an existing handler, so basically we'll unsubscribe first. Okay, so if there's an existing handler, we'll say return this dot unsubscribe queue existing handler. Right? And now we'll push the handler. So basically, if there's an existing handler, we'll unsubscribe, and then we'll push the handler to and attach the handler to that Q dictionary, right? Okay. Um, say this dot queues Q dot push handler. Okay, and here we'll return this dot unsubscribe Q handler. Okay, and I'll show you the unsubscribe in a moment. Okay, so Q unsubscribe Q handler. All right, perfect. Now, basically, this is where we invoke the handler, right? So first thing to do is assert the queue. So generate the queue, assert queue, pass it a queue name, durable, true. Okay, and we'll say this dot queues, queue name equals handler. And now we'll start the consume, right? So this channel dot consume. Okay, here, escape out of that. All right, so consume, we'll give it the queue name, and we'll call a method here, async message. And this is where we start to define or invoke the handler, right? So this is why it's so generic. You can invoke the handler of any event handler based on any queue that the handler subscribed to. So we'll create an acknowledgement. Okay, dot once. This dot channel dot ack the message. So acknowledge the message. This dot queues queue, and we'll say for each. Okay, we'll invoke the handler, right? So this guy will invoke the handler. So first get the event handler. So we'll call that EH mapper. Remember, we're relying on our mapper. Handler.name and some options. And then we'll call EH.handle method, passing it the message content. Content dot toString. Okay. And then we'll say dot then acknowledge. Okay. We need to close that. Need a semicolon there, comma, and semicolon. All right. And then basically we'll return this dot unsubscribe queue handler. Okay. So we kept calling this to unsubscribe, but remember we need a method for that. So async unsubscribe queue and handler basically detaches a handler from that queue, unsubscribe. So we'll say underscore dot pull this dot queues queue and the handler. Okay. That should do it for our implementation of the RabbitMQ bus. So module exports RabbitMQ bus. Okay. I believe that's what we call the class, right? Oh, it should be RabbitMQ bus. Sorry. Okay, so I'm going to save that. If we now head back over to our mappers, pub sub provider mapping, let's define this here. So since we have a bus ready, we'll say constant RabbitMQ bus require, and we'll say RabbitMQ bus. Okay. Here we're going to say class pub sub provider mapping. Define a constructor. Okay, we'll say this dot class mapping equals, and here we'll just define a list of all of our buses. So right now we have one, so that's the RabbitMQ bus. Okay, and here we'll create a getter that gets us the bus. Okay, so we'll say if there's no instance, then we'll say this dot instance equals new, and this dot class mapping, and we'll pass it options dot provider. Okay, and options. Okay, and we'll return this dot instance. So as we make or create more buses, we'll start adding them to the provider mapping. Okay. Here I'm going to module dot exports hub sub provider mapping. Okay. At this point, we should be able to work on our index.js to set up event handlers, right? And create the worker or invoke the worker. Okay. So what I'll do is, in the meantime, before we hit index, I'll create another folder in source. We'll call this the event handlers. Okay. So inside event handlers, we're going to create 3 event handlers. Again, feel free to play around with custom event handler that takes a message, calls AWS or processes a file and so on. Right now, I'm just going to showcase the power of this generic bus. So inside event handlers, we're going to create our first event handler. We'll call that Q1 event handler.js. Okay, so class Q1 event handler. Okay, now why did I name it this way? So remember, the name of my queue is going to be Q1, okay? And the event handler is going to be the name of the queue, then the word event handler. That's actually how our mappings work, right? They basically they create a dictionary of event handlers that are bound to this queue, so it follows the naming convention, and then invokes the handle method. So where's the handle method? We're going to define that now. So we'll have a constructor, default, and our important handle method. So handle method of an event handler takes the event in, basically pulls it from RabbitMQ through our message bus, right? And then for now, we'll just log it. But normally, you would have workers working on files, talking to AI, making API calls, third-party services, and so on, and doing, or maybe the backend, and doing something with the published event. Okay, for right now, we'll just log the event as it comes into the queue. So module.exports, and this would be our Q1 event handler. Okay, I'm going to copy this whole thing. We're going to create 2 more files. So new file, we'll call this the Q2 event handler.js. Copy that over. All I'm going to do is change that to 2. So we'll have 3 different queues to showcase this message bus. All right, and we'll add one more here. Q3 event handler.js. Paste. Make this Q3. And this is going to be Q3. Okay, I'll just save all. All right, so we got our event handlers, our 1 message bus out of the 3 we're going to work on, the Kafka and the Redis. And that's the RabbitMQ. Now we'll head over to index.js and start to implement the worker. All right, so let's go ahead and close everything except index.js. Okay, so here, what we're going to do is first bring in our provider mapping. So I'll say constant provider mapping require, and you're going to see how powerful this is. Source, message bus, mappers, hub sub provider mapping. All right, so that's our provider mapping. And then we're going to bring in our 3 handlers. So Q1 event handler, right? And that's require. That's coming in from source event handlers, Q1 event handler. Perfect. All right, I'm going to copy that twice. All right, for Q3, 2 and 3. Right, move over to this guy, 2 and 3. Okay, so very first thing, we're going to define a function here. That's going to be defining our provider. Who is our provider? Well, in this case, we're going to just use RabbitMQ. And we'll say provider init. And we'll say return new provider mapping. Okay, now the heart of our worker. All right, so basically, we're going to define a constant worker. We'll say start worker, async. Okay, so we'll add a try catch here. Okay, and we'll say console.log, and we'll say initializing provider. Okay, and here we'll say constant mapper equals provider init. So we'll create a mapper first. And from there, remember, we'll pull the actual bus out of there. All right. Okay. So after mapper, we'll define our RabbitMQ URL. So Rabbit URL. This is going to be our process.env.RabbitMQ URL. Or we'll just hard code it for now, AMQP, unless you define an env. We'll do that. This is going to be guest at RabbitMQ port 5672. Okay, and we'll just log some information here. You can see it in Docker. We'll say RabbitMQ URL. That's a RabbitMQ, and that's going to be our Rabbit URL. All right, so let's create our important pub sub option. So this is when you create a pub sub provider. Think of it as one of our brokers or buses. We want to give it some options. Again, it's nice because I can switch the config provider and switch from Rabbit to Kafka to Redis to SNS and so on. So we'll say constant pub sub options. All right, so we'll define a provider. In this case, it's going to be RabbitMQ. Make sure this is matching the name of our class for RabbitMQ bus. Okay, we'll give it a broker. It's Rabbit URL. Rabbit username. For now, it's guest. Rabbit password. It's guest. Okay, those are our pub sub options. Okay, now here's the important part, right? In one line, I can grab a hold of the bus, which is nice. I can say mapper.get and pass it the pub sub options. Okay, so remember our pub sub provider mapping knows that, hey, you give me some options. In the options, a provider name is defined. We're going to map that to what class is there. In this case, RabbitMQ bus class, and give you the bus back. Okay. So once I have a bus, we'll start to create some random messages in the 3 different queues, and watch our event handlers kick off. Right. So let's do a check here. We'll say if there's no bus, throw an error. Provider is not set. Okay, and now we'll start to subscribe to queues. So very first thing we want to do is subscribe to all the different queues. So we'll say subscribing to queues. And here we'll call await bus.subscribe. So we created that method subscribe within the bus, right? And what's argument? It's, the name of the queue. So it's going to be called Q1 event. Right? And then the handler. So it's nice, very, simple, keep it simple approach. Name of the queue and the name of the queue handler, which is a Q1 event handler. Right? And we'll give it pass a null for the third argument there. So I'll copy this 3 times. Okay, for all 3 queues. And we'll subscribe to the Q2 and Q3 events using the Q2 and Q3 event handlers. Okay. So we'll just put a message out on Docker. We'll say console.log. Subscriptions are now active. And console.log, we'll just say testing or starting message publishing loop. Okay. Basically, I'm going to create 10,000 messages, and you'll see how powerful RabbitMQ is. So basically, we'll say for and say let I equals 0, I less than 10,000. Create 10,000 messages, I plus plus. Okay, and here we'll create a random number between 1 and 3. Signifies our 3 queues. Math.floor, math.random number, and we'll say times 3, and then this is a generic algorithm to generate a random number between 1 and 3. You get semicolon there. Okay, so we'll say now await bus dot publish. Okay, so remember we have a publish to a queue. Which queue? Well, you can say Q1, but I'm going to randomize this. So Q $, random, so event. So this is a queue we're publishing to. And what payload? Well, we'll just define a payload here. We'll say message is, and this will show up in RabbitMQ. Q random message. Okay, so this should print out on the console once it reaches the event handler. All right, I'll close that up. Okay, we'll just say console.log worker finished publishing messages. Okay, and then basically we'll just log that, hey, the worker is waiting for new messages or incoming messages. And we'll keep it alive every 20 minutes with set interval. And again, different ways to do this. So here, we'll just say console.log worker heartbeat still running, ... Okay, and we'll give it every 20 minutes, right? So we'll say 20 times 60 minutes, 60 seconds times 1,000. Okay, so every 20 minutes. All right, so this should close our try. Yeah, so let's add a catch here. So we'll say catch error, and on error we'll just console.error, and we'll say worker failed, and here's the error. So we can see it in Docker. Okay, and basically it'll start the worker, right? We just call this start worker method up here. Okay, so let's give this a shot, and we'll check out the RabbitMQ management console and see if we start to see thousands of messages flowing into different queues and heading over to our different handlers. All right, let's go ahead and run our Docker container. So I'll say first thing is build. Okay, then we'll say docker compose up -d. All right, I'll pull up Docker here and go to containers. Yep, we see our RabbitMQ and message bus. Notice it's starting up, waiting for RabbitMQ. Let's give it a moment while RabbitMQ gets started here. And there we go. So look at this. It's publishing randomly to 3 different queues. So we should start seeing, you log into, so you're going to head over to localhost port 15672, log in with guest, and we should see our 3 queues here, Q1 event, Q2 event, Q3 event. And you should start to see the message rates go up. Okay, you see 40 per second, right? Starting to publish to different queues, right? The messages. So if you head over there, you'll see the incoming message rates. You know, each queue is random, so it's roughly between 6, 5, and 7, 5 and 8 messages per second coming into the queue. Okay, and remember, as soon as they come in, the handler's picking them up. So if you head over to Docker, you see the handlers are picking up these messages, consuming them, and then printing out the actual message that we sent. And look at this 10,000 flowing in nicely. Imagine you scale this to millions of records with multiple workers handling these queues, right? Or in batches as well. So that's how you build a generic message bus, okay? And then we'll get to the Kafka and the Redis as well.